Hello and welcome to today's session on differential calculus. In the last session, we discussed in details about sets, relations and functions. Today, we are taking up differential calculus. We shall be completing it today, and in the next day, we shall take up integral calculus. The calculus has two parts, differential calculus and integral calculus. Now, long back in the 17th century, Sir Isaac Newton and another well-known mathematician, Leibniz, they discovered the laws of calculus independently, and from then on we have both differential calculus and integral calculus. Now, when we talk of differential calculus, the first concept which we need to understand is function and the difference between dependent variable and independent variable. Now, if I write y equal to f of x, that is, y is a function of x, and you may remember, dear students, in the last class, we discussed about what is function, different type of functions like onto function, into function, constant function, etc. And fx is the way to denote a function. Now say fx is equal to x squared, right? So y equal to fx, function of x, which is equal to x squared. Now when we take the concept of differential calculus, we have a word which is called derivative. Derivative. What is derivative? Now, you see, we have y equal to x squared. Now, if there is a very small change in x, so here x, if you see, x is the independent variable because x can assume any values, but whatever values x assumes, y, the value of y, will depend on the value of x. So here x is the independent variable and y is the dependent variable. Okay, so we have independent and dependent variable. Now the question is derivative. If you see derivative of a function, the first and foremost concept in differential calculus is how to find the derivative of a function and what is the derivative of a function. Now, derivative of a function means that we are trying to find out a very small change in the value of x. That means if x changes by, say, a very small amount, let us call it delta x. As a result of which, if x changes, y will also change. Because x is the independent variable and y is the dependent variable, and the value of y will depend on the value of x. So if the value of x changes by a very, very small amount, then y will also change. The value of y will also change. And say the value of y changes by a very small amount, delta y, very small amount. Then the derivative of this function fx is denoted by dx. In other words, dy by dx. The derivative of y with respect to x. And this is nothing but the change in y divided by the change in x. That means we are trying to find out what is the impact in y, delta y, due to a change in x. And once again, x is the independent variable which can assume any numbers within the specific domain. You know what is domain. You know what is domain, codomain and range. So x can assume any number within the given domain. It can assume any value within the given domain, as a result of which y will also change. And this delta actually means, delta y means the impact or the amount of change in y due to a change in the value of x. So derivative is defined as delta y by delta x. It is shown by dy by dx, where y is a function of fx. So y is a function of x, y is equal to fx. Right? So this is the basic concept of differential calculus, where we are trying to find out the impact of a change in the independent variable. What is the impact of a change in the independent variable on the dependent variable y? Now, I can give you another example. Derivative measures, I can say that derivative measures the rate of change. I can write this. Derivative measures the rate of change. That means the rate in which y, the value given in y, changes as a result of the change in x. So please note, it is delta y by delta x, which means a very small change in x. We call it infinitesimal, infinitesimally small. You will see it in the study material also. In various pages of the study material, you will find the word infinitesimal, infinitesimal. That means it is a very, very small change, infinitely small. Now, last day I discussed about infinity. Infinity is not a number, but a symbol. Similarly, infinity can go into plus infinity, minus infinity, and infinitesimally small. The word infinitesimal means very, very small change. Right? A very, very small change in x, as a result of which the corresponding change in the value of y. So if x changes, the value is x square, the function is x square. If x changes by a small amount, definitely there will be a change also in y. Now it will also be very small. So derivative measures the rate of change in y as a result of the rate of change in x. So this is a concept in mathematics, but it has applications in economics, in finance also. That is why we are studying differential calculus and integral calculus, because it has a direct impact on economics, especially when we talk about price elasticity of demand. You know that the demand depends on price. So the rate of change of demand due to a rate of change of price is another application of derivative. So if I say that the demand is, say for example, given by y, and the output, the price is, say, the demand is y, and say the price is x. So the rate of change of demand due to a rate of change in the price, as you know that if the price increases, normally the demand will fall, and when the price falls, demand goes up. So here, price is the independent variable and demand becomes the dependent variable. So the concept of differential calculus is used in mathematics, in economics, in business, in finance, also in physics. A small example, you know that when we talk of the word acceleration, acceleration means the change in velocity of a vehicle, of a body. When a car accelerates, it means the velocity is increasing. So I can say that acceleration, ACC, is equal to differential or derivative of the velocity dv by the time dt. So it is a rate of change. It is a rate of change in the velocity by time. The rate of change of demand due to a rate of change in the price is another example. So derivative measures change, rate of change, and it is basically what? It is basically measuring the rate of change in the dependent variable y as a result of a change in the independent variable, that is x, and the changes are minute. That is why it is called infinitesimally small. Very, very small changes. So Similarly, the savings of a person, how much you save at the end of 1 month, how much you save at the end of 1 year, the rate of savings depends on income. The rate of savings depends on consumption. So the rate of change in savings due to a change in the income is another type of derivative. So if I say that S is the savings and I is the income, then the rate of change in savings of a person due to a change in the income of the person will be ds by di. So this is the concept of derivative. So basically, please remember it is delta y by delta x, and it is denoted by dy by dx, where y is a function of x, and derivative measures the rate of change in the dependent variable, that is y, as a result of a change, a very small change of course, in the independent variable, that is x. Now let us go into section 8a.1 of the study material. Please open page 8a, section 8a1. So it is section 8.a.1. So differentiation, also called differential calculus, is a very important fundamental operations of calculus, and it depends on limit and continuity. Some of you who have got maths background, I am sure you have studied limit and continuity in your +2. And when we say that delta y by delta x, it means the change in the dependent variable y and the independent variable x is of the smallest amount imaginable. It is an infinitesimally small amount, and this derivative is trying to measure the change at y in y due to a change in x, but the changes are very, very small. So please note, I am repeating the word infinitesimal. It is very small change. You can see the study material. There also it is clearly mentioned that the changes will be very small change. Okay. So now we can say that derivative is a rate of change. I gave you 3 examples. The first one is this function y equal to x square. The second is an example of acceleration, which I wrote that it is nothing but a change in velocity, the rate of change of velocity with respect to time. Now, very frequently we hear you compare 2 cars. Which car is faster? Car number 1 accelerates from 0 to 100 kilometers in 9 seconds. Car number 2 accelerates from 0 to 100 kilometers per hour in 6 seconds. So second car is faster. Why do you say it? Because the change in velocity, initially it is 0, finally it becomes 100. The change is same, 100. But in the first case, the first car starts from 0, reaches 100 kilometers per hour within 9 seconds. But in the second case, it takes 6 seconds. The second car takes 6 seconds to reach 100 kilometers per hour. That means the rate of change of velocity in case of the second car is higher. It is more fast. It achieves 100 kilometers per hour speed in 6 seconds, whereas the first car takes 9 seconds. That means here also acceleration is dv by dt, where v is the velocity and t is the time. Right? So the rate of change of velocity with respect to time is acceleration, shown by dv by dt. Similarly, rate of change in y, in this case y equal to x square, due to a change in x, a very small change in x, that is dy by dx. Similarly, the rate of change in savings, the rate of change in profit due to a change in price will be shown by like ds by di, savings by income, where savings of a person means it depends on income. So it is a function of income. More the income, consumption remaining the same, more will be the savings, and vice versa. So savings like y equal to x square is also a function of income, right? So that is why, dear friends, we discussed about function in the last class, and I mentioned, you probably remember, that the session on sets, functions and relations is the basis on which differential calculus and integral calculus depends. So it is the basis, and that is why we are able to discuss differential calculus today. So differential calculus or derivative, which deals with derivative of a function y equal to fx is defined as the rate of change in y, that is the dependent variable, due to a very small change in x, which is the independent variable. This is shown by dy by dx. It is also shown by another symbol, that is f dot x. Fx we know, fx is y equal to fx, but when we find the derivative of fx, we call it f dot, f slash x. A small slash at the top, f slash or f dot x. Right? Now, we see what exactly is this change. Okay, I was talking about the change. Now, what exactly is the change? Okay. I was also mentioning that if you see the study material, it is mentioned that derivative or differential calculus depends upon limit. There is a word called limit. Now, what is limit? Let us see. So, derivative of a function, say fx is equal to y. So, the derivative delta y by delta x basically is equal to f of x plus h. Please see this carefully, and if possible, please note it down, because we are discussing the most important concept in the derivative. Understanding the remaining formula, right? So, when we say that y is a function of x, and when I say that I want to find out f dot x, that is the derivative of x. Derivative is also called differential coefficient, right? Derivative is also known as differential coefficient. How do we find it? Conceptually, using concept. Function of f, function x plus h minus function of x divided by h when the limit is h tends to 0. This is very important. Please try to understand this. Okay. So, function is x, fx. H, which you see, h is tending to 0. H is tending to 0. That means h is moving towards 0. Small, smaller, very small, going towards 0. 0.1, 0.01, 0.00009, 0.0000005, like it's becoming smaller and smaller. It is moving towards 0. That means fx plus h means what? It means x plus an additional part h. But this part h is very small. It is infinitesimally small. Why? Because you see, it tends towards 0. Arrow, the arrow which you see here means it is moving towards 0. It is slowly traveling towards 0. It is tending to go towards 0. You know the word tendency. Okay, so it is tending towards 0. As h moves towards 0, that means f of x plus h is very small change. It is a change, no doubt, but very small. So this fx plus h is the change in the function fx due to a change in the value of x. So this minus the original fx divided by h gives you the rate of change. So this gives us the ROC, that is the rate of change. and this is called dy by dx. Okay, so dy by dx is the differential coefficient of y. Y is a function of x with respect to x. It is also called the derivative, plus the formula is function x plus h minus function x divided by h when h is moving towards 0. So the limit of h is 0. H is moving towards 0. And this is called f dot x also. So differential coefficient, derivative, f dot x, all of them mean the same. We are trying to find the rate of change in the dependent variable y due to a very small change, infinitesimally small change in the value of x, which in this case is the independent variable. This is differential coefficient. This is what is derivative, and I gave 3 examples. First is this simple, the formula which I have written, the simple function. Second is I talked about the difference of the 2 cars. The first car accelerates to 100 kilometers per hour in 9 seconds. The second car accelerates to 100 kilometers per hour in 6 seconds, which means the rate of change of velocity of the second car is higher. It's more. That means the second car is faster because it accelerates faster. So dv by dt, if you think of velocity as dv and with respect to time dv by dt, this measures the rate of change in the velocity. Here dy by dx measures the rate of change in y due to a change in x, and similarly marginal propensity to savings is shown by the rate of change. We always try to measure the rate of change in savings due to a change in the income of a person. So this is rate of change, right? Now that means here 2 things. X is, you can call it, definitely it is the independent variable. You can also call it input. So x is here, you can call it input also. X is the input, y is the output. One is input, the other is output. X is the input, y is the output. X is the independent variable and the value of y depends on x. So y is the dependent variable. Right? Let's now move to 8a2. So section 8a2, you will see this formula is given there. In the study material, please see f of x plus h minus fx by h as h tends to 0. Limit h tends to 0. That means the limit of h is moving towards 0. Small, smaller, infinitesimally small. Right? So that day I discussed about a numerical in GP. I took the example of a ball and the ball was bouncing. It was thrown from a height of 100 meters. It is bouncing up to 4/5 of its height and slowly it is bouncing like this. So you see, it is infinite, and later on as it bounces on, it will cover the amplitude. Initially it is this much. Then slowly it will be lesser. It will still bounce, but it will be small, infinitesimally small. That means limit h tends to 0. That means the difference is very small, but still we want to find what is the impact of this infinitesimally small change in the value of x and the impact of it in y. Okay, so this is, I'm sure now it's clear to you, this is the derivative. This is also called the differential coefficient, and therefore dy by dx you can say is f of x plus h minus fx by h as limit h tends to 0, and the differential coefficient measures the rate of change. Here we are measuring what is the rate of change in y due to a change in x. In case of acceleration, we are measuring the change in velocity, the rate of change in velocity of a vehicle with respect to time. So this is derivative. And as we saw, that derivative has many ways, many symbols. Okay, so we saw that it can be dy by dx, which shows basically it is derivative of y with respect to x. It can be shown by delta y by delta x. It can be shown by f dot x, and this is also equal to limit h tends to 0 f of x plus h minus fx by h. So all of them are same and all of them mean derivative or differential coefficient. Okay. Now let us look at the rules of differentiation. There are certain rules because here we will be dealing with functions. The first rule, I will write the rules here. So I think this is clear. dy by dx is the differential coefficient of y with respect to x. Y is a function of x. Therefore, x is the independent variable. Y is the dependent variable. Function can be of different types. I'm just giving few examples. It can be fx, that is y equal to x square. I took a quadratic function. It can be something like this, log x to the base 10, for example. It can be trigonometric functions. Of course, it is not there in the curriculum. I'm not going into it. It can be something like this. For example, y is equal to square root of x. It can be something like this. Y equal to 4x cubed plus 6x square plus 5. Okay. So it can be any of these functions. And we shall see how to find the differential coefficient of all these functions. Because these are part of our syllabus for the exam. Right. So now we proceed to the next part, and that is we will now look at the rules of differentiation. Okay. So we have discussed part 8a1 and 8a2. We have seen that derivative of a function is the differential coefficient, number one. Number two is we have also seen that it shows it measures the rate of change in y due to a change in x, where x is the independent variable and y is the dependent variable. It is shown by different forms. It can be dy by dx. It can be f dot x. It can be delta y by delta x. Different ways. The concept is same. The form is different. And we have seen it is called derivative. It is also called differential coefficient. Now we go to the rules, and the first rule we will take is the power rule. The power rule. So now we go to the rules of differentiation. Right. The first is, so we will take the rules of differentiation, and the first rule we take up, if you see, is the power rule. The power rule means let y equal to x to the power n. That is why it is called power rule. The first one is the power rule. Y equal to x to the power n. Now, if I tell you that what will be the differential coefficient of this function, so y is x to the power n. So dy by dx is equal to how much? The rule is x to the power n. So dy by dx is equal to, you have to remember these formulae. There are 6 or 7 important formula which are part of the exam, part of your syllabus. So x to the power n, this will become n into x to the power n minus 1. Right? However, the proof of all this is beyond the scope of our discussion. First of all, we don't have so much of time because we have to complete the session strictly in 2 hours. Max to max, we'll take 15-20 minutes extra. Secondly, this is beyond the scope of our exam because in exams no proof will come. However, if you want to prove it, you can prove it by using that formula which I showed here. Limit h tends to 0, f of x plus h minus fx by h. This is the fundamental concept. This is the fundamental theorem, you can call it. F of function of x plus h minus function of x by h, where h tends to 0. This is the fundamental concept of differential calculus, and it's a limiting condition because h is moving towards 0. Infinitesimally small. Right? And this is the first formula, so I'll write A. That means, if, say you are given d dx of x to the power 5, you have to find the differential coefficient of the derivative of x to the power 5. So here, n is equal to 5. The formula is x to the power n. If you find out the derivative, it will become nx n to n minus 1. nx to the power n minus 1. So x to the power 5 will become, here n is 5. So n, so 5 into x to the power 5 minus 1, that is 4. So this is the first formula which we note. The next one, d dx is the first one. d dx, the differential coefficient of a constant, say it is c. C is a constant. Like you know, an example of a constant is, if I write, say, you know there's a symbol called pi. When you find out the circumference of a circle, it is 2 pi r. 2 pi r. When you find out the area of a circle, it is pi r square. And many of you remember that pi in mathematics has an approximate value of 22/7. So, pi is a constant, right? So, if you have a constant, any number for example, d dx of that will be 0. So, if I tell you that please find out the derivative of 6. So, d dx of 6 is equal to 0 because 6 is a constant. So, derivative of any constant is 0. This is number B. So, we have noted the rules A, B. Okay. Now, we go to the next one and we see a power function rule. Okay. The third one. So, x to the power n we have seen nx n minus 1, nx to the power n minus 1. I have taken the example of x to the power 5. If I write, say, x to the power 9, right, x to the power 9, then the differential coefficient will be 9x to the power 8. Okay, nx to the power n minus 1. Correct? So this is the first two formula. Now we go to the third formula, that is formula number C. And I will talk about the power function rule. Okay. The power function rule states that if y is equal to a into x to the power n, a is a constant, okay, a into x to the power n, then the derivative of y, that is the differential coefficient dy by dx will be equal to n will come down, so it will become, a will remain as it is. A is here. N will come down. X to the power n minus 1. So this is the third formula C. So we are looking at formula C also. Okay? That means, if I say an example, d dx of 4x squared. This is of the form ax to the power n. Here, a is 4. X as it is there. N is 2. So, a is 4, n is 2. So, it is of the form a into x to the power n. Now, if I differentiate this, it will be what? N will be here. So, this 2 will come down. 2 into 4, x to the power 2 minus 1. That is, 2 into 4 gives me how much? 8. So it is 8x because x to the power 2 minus 1 means x to the power 1 and that is x. So we have 8x. Okay. So this is called the power function rule. First one was the power rule. Then next one was the constant. Derivative of a constant is 0. And the third is the power function rule. So this is C. Now we will take a negative value. Okay. So let us take a negative value. Let's take, why don't we take 4x to the power minus 2. So negative power. 4x to the power minus 2. The same formula will be applicable n a x to the power n minus 1. So in this case n is minus 2. So instead of 2 it will be minus 2. 4 will be there. And here instead of 2 it will become minus 2. Minus 2 minus 1. So it will become minus 2 into 4 is minus 8. X minus 2 minus 1 is minus 3. So it will become minus 8 by x cubed. Or you can show it as minus 8 x to the power minus 3. Right? So therefore please note this is formula number C and this formula is applicable for any values of n. N can be positive, n can be negative. The same formula will be applicable. Okay? We now proceed to the next one and that is the sum and difference rules. Okay. So we proceed to the next one and this is going to be the sum and difference formula. Okay. As usual, I normally don't see the queries during the class because it takes away valuable time. It distracts the flow of the class, right? Because many queries keep coming. I will look at it later on and if time permits, because we are given a strict time of 2 hours, I'll stretch it maximum 10-15 minutes, right? But then we have to wait for next sessions if available. If we get time, then we shall be able to take the queries. Wherever responses are there, I normally send the responses immediately on the next day. So I'm sure you have seen the responses. But if there is a problem if you have a doubt about a particular problem, unless we get sufficient time, it is not possible to solve those problems, right? So let's move on to the next one and let's see the addition rule. And I will look at the queries only at the end of the class. I never look at the queries during the class. It breaks the flow of the entire presentation. It takes away time. Okay. So please wait for some time to get answers to your queries. Some people become very impatient. That's why I'm telling you. Now, the sum and difference rules. If there are two functions, one of them is fx and the other one say is gx. So, if you are told that yes, you have to find out the derivative or the differential coefficient of the sum of these two. So, d dx of fx plus gx. Fx plus gx. So, this is formula number D. The sum one. The sum formula. So the formula states, it's very simple. The formula states that in the case of two functions being added, the differential coefficient of the sum will be the sum of their individual derivatives. That means this is equal to d dx of fx plus d dx of gx. Okay, so d dx of fx plus d dx of gx. This is the addition rule, or you can call it the sum rule, right? So there are two functions. We will take more examples of the functions. Let us first see the formula, then we shall take examples. So fx and gx, if you see, two functions of x. And if you have to find out the sum, fx plus gx, you need to find out their differential coefficient. d dx means you know derivative or differential coefficient. Then what we need to do is, we take the derivative separately, which means this is equal to f dot x. F dot x you know is the derivative plus gx, so it becomes g dot x. So this gives you the addition formula for differential coefficient calculation, and it is also called the sum because you are summing up two functions of x. This is formula number D. Okay, so this is, please note, is D. Now we go to formula number E, the next one, which is regarding the rule of difference. So here we were summing up, but now we will go for difference. Fx minus gx. So if you have to find out the derivative of two functions, the difference of two functions, the formula is simple. Instead of plus, we will just rub it out and we will write minus. In this case also, ddx of fx minus ddx of gx, which means it becomes f dot x plus, I removed, it becomes minus g dot x. And this becomes formula number E. So I will be writing here formula number E on difference, which we have covered. Okay, so this is the formula on addition, the formula on subtraction. Now we are left with the next formula, which basically is of product. But before that, we will take two examples of these two. Okay, so that you have clear concept. So I would just rub this up and I would write two functions here. So if y is equal to 2x squared plus 3x. 2x squared plus 3x. Please note two separate functions. Okay? 2x squared is one particular function and 3x is another function. What will be the differential coefficient of this x, this particular expression? So, what we do is applying the standard formula which we have done, A, B, C, D. Okay? Power formula, constant power formula, all those formula which we saw, addition formula, subtraction formula, are known as the standard. They are the standard formula for differential calculus. To find out the derivative, to find out the differential coefficient. Therefore, let's see the rule here. So the rule will be like this. We will break it up. So dy by dx is equal to d dx of 2x squared. 2x squared plus d dx of the second function, d dx of 3x. So this is by applying the addition rule where we are trying to break up these two separately. Now 2x square means it is of the form ax to the power n. And we know, we have seen earlier few minutes back that the differential coefficient of ax to the power n is given by na to the power x minus 1. So 2x square, the derivative will become this 2, the power 2 will come down, this 2 will remain, to the power x, 2 minus 1, plus ddx of 3x. 3x means 3 will be there, x to the power what? What will happen? We had x means x to the power 1, so it becomes 1 minus 1. So this is equal to 2 into 2 is 4, so we have 4x, because x to the power 2 minus 1 is x to the power 1, which is x, plus 3 into x to the power 1 minus 1. 1 minus 1 is 0. Anything to the power 0 is equal to 1. So it is just 3. So this is 4x plus 3. The differential coefficient of 2x squared plus 3x is 4x plus 3. Okay? So this is the differential coefficient of the by applying the addition rule. Now we are seeing another one an easier one. I'll put it this way, an easier one. And let the function be y equal to 5x plus 4. Y equal to 5x plus 4. We have to find dy by dx. That is the derivative of y. In other words, the differential coefficient of y with respect to x. You can see once again, I am repeating, y is the dependent variable and x is the independent variable. Okay, so here we apply the same rule. So it is d dx of 5x plus d dx of 4. So we split, we break it into two parts. Part by part we are differentiating. 5x means 5 into x to the power 1 minus 1 plus d dx of 4. Now 4 is a constant. 4 is an integer. It's a positive integer. It's a constant. And we know the differential coefficient of a constant is 0. So this is 0. So the answer is now 5x to the power 1 minus 1. 1 minus x to the power 1 minus 1 becomes 0. X to the power 1 minus anything to the power 0 becomes 1. So here x to the power 1 minus 1 means x to the power 0, which is 1. So it is 5 into 1 plus 0, that is 5. So this is how we differentiate 5x plus 4. Fine. Now we move on to have a look at some more examples quickly. Okay. So as much of examples as possible as time permits. Okay. So quickly we shall see if fx y is equal to fx equal to x cubed. So nx to the power n. So it will become mxn minus 1. Nx to the power n minus 1. So the differential coefficient, that is dy by dx, becomes 3 into x to the power 3 minus 1, which is 3x squared. Fine. Now we take y is equal to, another example, is equal to 2 x to the power 9. 2x to the power 9. So this is of the form axn. Ax to the power n. So dy by dx is equal to, the 9 will come down, 9 into 2 into x to the power 9 minus 1, n minus 1. So it becomes 9 into 2 is 18, x to the power 9 minus 1, that is 8. So it becomes 18 x to the power 8. I'm sure it's clear, and these are very simple formula, nx to the power n minus 1. Okay. Now let us take the product rule. So we have seen the addition rule, we have looked at the difference of two functions, and now we shall have a look at the product rule. Before that, one more example of sum and difference. Okay, I will take one more example here. So please practice with me. Here, say, let us take this example. Say y is equal to, let us take 5x squared plus 7x minus 6 plus 7x minus 6. Okay. 5x squared plus 7x minus 6. This is y. So you can see it has three separate parts. 5x squared, first part, 7x, second part, and 6 minus 6, the third part. So we apply dy by dx and the formula which we have just learned, that is formula number d on summation and formula number e which is on subtraction. So what does the formula give us? The formula tells us that in this case dy by dx is equal to d dx of 5x squared plus d dx of 7x minus d dx of 6. So we have broken down the entire expression into three parts and we are finding the differential coefficient of each of them separately. Okay? So 5x square is of the form ax to the power n. You know the formula n a x to the power n minus 1. So this becomes 5 into 2 into x to the power 2 minus 1 plus 7 into x. So it becomes 7 into x to the power 1 minus 1. And we know that the differential coefficient of constant is 0. So we have minus d dx of 6. So it becomes 0, minus 0. Because we know the differential coefficient of a constant is 0. So the expression reduces to 5 into 2 is 10x to the power 1 because 2 minus 1 is 1 plus 7. X to the power 1 minus 1 is x to the power 0 which is equal to 1. So 7 into 1 is 7. So 10x plus 7. Fine. So in this way we break down. Now we shall take a bigger one. A bigger one. Or type of questions you get in the exam. These are the type of questions which comes in the exam. Okay. So we will take a bigger one and a complicated one. Little bit complicated compared to what we have done so far. So I am taking gx, a function of x, gx is equal to 4x to the power 6. 4x to the power 6 minus 3x to the power 5 minus 10x squared plus 5x plus 16. Okay, I keep the formula here. I am not disturbing the formula because this is the fundamental formula which you need to know. Okay, so let us look at how to differentiate this. 4x to the power 6 minus 3x to the power 5 minus 10 into x squared plus 5x plus 16. So we break it up and let us see what happens. First one is d dx of 4x to the power 6 minus d dx of the next one 3x to the power 5 minus 10. So we have 10x squared. So d dx of 10x squared plus d dx of 5x plus d dx of 16. So this is a bigger one, a longer expression. So we break each of them. First is 4x to the power 6. 4x to the power 6 means it is of the form nx to the power a x to the power n. A for 4. Here a is 4. So a x to the power n. So if you break it up, it becomes 4 into 6 into x to the power 6 minus 1. A n x to the power n minus 1 minus 3x to the power 5. So it becomes 5 into 3 into x to the power 5 minus 1. Minus we have 10x square, so it becomes 10 into 2 into x to the power 2 minus 1. Plus we have d dx of 5x. 5x is 5 and d dx of 16. The last one is 16. 16 is a constant. So the derivative of the differential coefficient of a constant is 0. So the last one will be 0. So we simplify this. You have 4 into 6, that is 24. X to the power 6 minus 1, that is x to the power 5. So I write x to the power 5 minus 5 into 3, 15. X to the power 5 minus 1, that is 4. Minus 10 into 2, that is 20. X to the power 2 minus 1, that is 1. So it remains minus 10x, minus 20x plus 5. So this becomes the final answer, and you can see this is how 24x to the power 5 minus 15x to the power 4 minus 20x plus we have 5. Okay. So this one is a bit complex. That's why I broke it down into parts, and this is an application of both the addition formula, that is formula number D, and formula number E, which is on subtraction. Now we proceed to another example. Okay. So please practice with me. Once again, my standing request to all of you is to do as much of practice. Now I remove this one, this formula, f into x plus, function x plus h minus fx by h, as h tends to 0 is the differential coefficient. Now we take up a new problem. Y is equal to 3x square minus 2x plus 1. So here we divide, we break it down, we divide the entire given expression into parts. We divide into parts and differentiate them individually, differentiate them separately, applying the positive, the addition rule and the subtraction rule. So this will become dy by dx will be equal to d dx of 3x square minus d dx of 2x plus d dx of 1. Fine. So d dx of 3x square is of the form a into x to the power n. So the first one will become 2 into 3. This 2 will come down into 3 into x to the power 2 minus 1. Minus, we have d dx of 2x. This becomes 2 into x to the power 1 minus 1. Plus d dx of 1. 1 is a constant number. 1 is not a variable, it is a constant. And the derivative of the differential coefficient of a constant is 0. So we have plus 0. So this simplifies to 2 into 3 is 6x to the power 2 minus 1, that is x, minus 2 into x to the power 1 minus 1. So it becomes 2 into anything to the power 0 we know is 1. So x to the power 0 is 1, so it becomes minus 2. So 6x minus 2 is the derivative, that is, if you call it f dot x or dy by dx, same, both are same. The answer is this, 6x minus 2. Right, now let us take, let's go to page number 8.6 and we shall take some example from the study material. I think they are becoming clear to you. The formula is simple and we are taking more and more examples. Now this is page 8.6 and we are taking a particular example in the study material, which is given in the study material. So we have to differentiate the functions with respect to x. I'll take the first one. It is given that y is equal to 3x square plus 5x minus 2. 3x square plus 5x minus 2. 3x square plus 5x minus 2. So we carry out the derivative by the same principle, applying the same formula number D and E, sum and difference application. So we first find out dy by dx is equal to d dx of 3x square plus d dx of 5x minus d dx of 2. Okay, so this is the direct application of the formula. Now 3x square, d dx of 3x square, it becomes 2, the 2 comes down into 3 to the power 2 minus 1 plus 5x, 5 remains as it is, x 1 minus 1, x to the power 1 minus 1 minus d dx of 2. Now 2 is a constant and derivative of a constant is 0. So we have 0. Therefore, the form becomes 3 2s are 6x plus 5 into x to the power 1 minus 1 is 5 into 1, so 5. The answer is 6x plus 5. Right. Okay, now we will take two more, or I'll move on to product rule first, then we will take two more formula. Okay. Now it's time for the product rule, and we proceed to the product rule when we have product of two functions. So we have looked at formula D and E. D deals with the addition of two functions, and E deals with the difference of two functions. Now we have the product rule. So I will put it in this way. Say y is equal to u multiplied by v. U multiplied by v. Y is equal to u multiplied by v, where u and v are functions of x. Okay? So you have to find out dy by dx. Okay, so the product rule says that when you have u into v, okay, when you have u into v, the idea is first you keep u here and first you differentiate v. So keeping as it is, so say for example u is equal to function of x fx and v is equal to say gx. So u and v are both functions of x. U is fx and v is gx. Correct? U and v are two functions of x and they are multiplied. Y is equal to u and v. Right? So I hope, dear students, you are following and things are clear. You are able to understand the applications. We did number of numericals on the addition and the subtraction. Now we are taking up the product rule, and this will be formula number F on the product rule. Okay, so here the principle given in calculus is that you first keep u outside and first you differentiate v with respect to x. So u into dv by dx plus, now you keep v outside and you take du by dx. So this is the principle. First, when you have uv, first you keep u outside, differentiate v, so u into dv by dx plus v into du by dx. Right? So let us try and take an example on this. Okay. Let me take this one. Or this is, say we want to find out, say y is equal to function of two, it's a product of two functions. So say, I write here, say fx is equal to 3x square minus 1. Okay, 3x square minus 1, and gx, the other function gx, is equal to x square, let's put it this way, x square plus 5x plus 2. Okay, so you have one is 3x square minus 1 and the other function is 5x square, x square plus 5x plus 2. These two functions are multiplied. Okay, so fx and gx, and say u is equal to fx and v is equal to gx. So now we have to find dy by dx because y is equal to u into v, and you can see the values of u and v is given. U is equal to 3x square minus 1 and v is equal to x square plus 5x plus 2. So dear students, we are about to apply the product rule, that is formula number F, what I did here, and the principle is like this. I will keep first, u is 3x square minus 1, I will first keep it outside. So 3x square minus 1, I am not touching this, I am keeping it outside. First, I will differentiate x square plus 5x plus 2. I am going to find out the derivative of x square plus 5x plus 2. And if you do the derivative, this will become x to the power 2. So it becomes 2x plus 5x. Derivative will become plus 5. And last, we have 2. The 2 will become 0 because derivative of a constant figure, a constant term is 0. So this becomes 2x plus 5. So the first part is over. Okay, plus. So I write plus here. Now v will be kept here. So v is x square plus 5x plus 2. V is kept outside. So I will write x square plus 5x plus 2 outside, and I will do d dx of the first one, that is u. So it is 3x square minus 1. If I carry out this operation, it becomes, of course, I write it 3x square minus 1 into 2x plus 5 plus x square plus 5x plus 2 into d dx of 3x square minus 1. 3x square is of the form a x to the power n. So the differential coefficient will do, it becomes 6x. And minus 1, differential coefficient of 1 being a constant number, is 0. So 6x remains as it is. So this we have to simplify, and if you multiply throughout and simplify, it will come to 12x cubed plus 45x squared plus 10x minus 5. Okay. So this part, of course, is computation. First, most important part is here. The way we have broken down, we have first taken u is kept outside, v is differentiated. So in this case, x square plus 5x plus 2 is differentiated. We have got 2x plus 5 plus the second part. Now what happened? V is kept outside. So x square plus 5x plus 2 is kept outside, multiplied with d dx of the first one. The first function is 3x square minus 1. And after that, we have got this particular expression, and it is further simplified. Okay. Now we shall take one more example, and let me take another example of product rule. So I would request you to carry it out independently with me, and I'm explaining, so I will take a little more time because every step I'm explaining, and please appreciate the difference of mathematics and other subjects. Other subjects, many of them are theory subjects. This is a practical subject, first of all. Secondly, majority of you may not be having mathematics background. So it is not like accounts, because accounts is also practical, but accounts most of you know. But mathematics is totally different from other subjects. Therefore, we go slow. I break down each and every step. I try to do as many problems as possible, often stretching the class beyond 4, sometimes going till 5 only for you. And the idea is to do as many problems because it is not like other papers. And you can understand the main issue is in accounts or in other subjects, once all the chapters are related, here all the chapters are different. For example, permutation combination has no common parts with differential calculus. Time value of money and indices chapter are totally different. Sets, relations and functions and matrices are totally different. So it is not like economics or law or accounts or other papers where the chapters are related. That is why mathematics is a critical paper. Even same thing for statistics, right? So that is how I proceed. Let us take the other one. Now we have y is equal to x square minus 1 into x plus 5. X square minus 1 into x plus 5. So we have to find the differential coefficient. Or you can call it the derivative. So the idea is to find dy by dx, or you can call it f dot x. This is like u and v. So the first one is u and the second one is v. So applying the product rule, that is formula number f, right? F for fan, which you have just noted. So what we do is, first x square minus 1 is kept outside and we do d dx of x plus 5. Okay. we are doing ddx of x plus 5. So u is kept outside, ddx of v plus, now we take x plus 5 outside and we are doing ddx of x square minus 1. So it becomes x square minus 1. ddx of x plus 5 is simple. It is 1 because x becomes 1, 5 is 0. So into 1 plus x plus 5 into x square minus 1. ddx of x square minus 1. X square is of the form x to the power n. So the formula is n x to the power n minus 1. So x square will become 2. That is n x to the power n minus 1. So 2 minus 1. And this minus 1, ddx of minus 1 is 0. So this is x square minus 1 plus x plus 5 into 2x. Now if I simplify this, let us see where it leads us to. So we have x square minus 1 plus 2x square plus 10x. So I think we are getting 2x square and x square, that is 3x square plus 10x minus 1. Okay? So we have done enough number of numericals on the product rule, and now we proceed to the quotient rule, that is formula number G, which is on the quotient. Quotient means now we will take, up till now we were taking u into v, two functions of x, u into v. Okay, now it will be u divided by v. So v becomes the denominator, u becomes the numerator. Let us see what will be the formula. And we will do practical as well. Fine. So I am taking up the next one, and that is the quotient formula. And here the same thing, functions of x, u and v. U is fx and v is gx. And we are taking a situation where y is equal to u divided by v. In the last formula, we have seen u multiplied by v, the product of two functions. Now it is, we find a situation where one function is divided by another function. So let us see the differential coefficient formula. So in this case, what we do is, again, dy by dx will be equal to, first, v is the denominator. So v is kept outside, v into du by dx. So we differentiate the numerator first. We find out the derivative of the numerator first. Minus. U is kept outside. Now we find dv by dx. So we find out the differential coefficient of the second expression. That is v. The second function we have got, v. Divided by v square. The square of the second function. So dy by dx, in case of y equal to u by v, we divide it in this way. V, that is the denominator, second function is kept outside. We calculate du by dx minus u, the first function, multiplied by dv by dx divided by v square. Okay, so this gives us the formula. And now let us see an application of this. So I am taking up an easy example initially. So let's take up, let u is equal to x plus 2 and let v equal to x plus 4. So we are trying to find out y is equal to x plus 2 by x plus 4. We have to find out the differential coefficient of y, which is equal to x plus 2 divided by x plus 4. Fine. What to do here? How to proceed? So the formula is in front of us. We will just apply the formula step by step and we shall find out the result. Right? So we take up v first. V is x plus 4. Correct? So I keep v outside. X plus 4 is kept outside. I do ddx of x plus 2, the first function. So x plus 2. Minus, please remember the minus sign here. Minus u. U is x plus 2. So I keep x plus 2 outside and I find out the derivative of v. So I find d dx of x plus 4 and I divide the whole thing by x plus 4 whole square because we have v square. In the denominator, dear students, we have v square. So we divide throughout by v square. So let us see what this formula gives us. Now, this equals x plus 4 as it is. X plus 2, differential coefficient of x plus 2 is 1 because x will become 1, so 1. Minus x plus 2 is outside. Differential coefficient of x plus 4 is also 1, so 1. Divided by x plus 4 whole square. Okay, so this, when simplified further, gives us x plus 4 minus x minus 2 by x plus 4 whole square. So x and x cancels out. 4 minus 2 is 2. 4 minus 2, yeah, 4 we are having 4 minus 2. Just check whether we are correct or not. X plus 4 we have taken, x plus 2 minus x plus 2. So we are having x plus 4 minus x plus 2. Okay, so it becomes x minus 2. Okay, so it is x minus x cancels out. We are having 4 minus x plus 2 was there. So it becomes minus x minus 2. So it is 2 by x plus 4 whole square. Okay. So in this way, we are able to break it down and we are able to find out how we take care of problems like this where you have y is equal to u by v and both are functions of x. For example, here we took u is x plus 2 and v is x plus 4. Okay, so this is the way to solve these type of numericals. And now we will look at another example and let a little bit longer problem, not like the immediately last one, x plus 2, x plus 4 was very simple. Let us take, let hx, okay, let hx, hx function of x is equal to hx is equal to 2x by 3x cubed plus 7. So we need to find out the differential coefficient of this. So y is equal to hx. So we need to find out dy by dx. So we are applying the quotient rule or the quotient formula, formula number G. And we are directly going into breaking down the given expression into this. So we first take v outside and we carry out 3x cubed plus 7 into d dx of 2x, which is the first function, the numerator, minus, we keep 2x outside and we carry out d dx of 3x cubed plus 7 and we divide this by 3x cubed plus 7 whole square. Right? This, when further simplified, let's see what it brings down to. 3x cubed plus 7. dx of 2x is what? 2. Because x to the power 1 minus 1 becomes x to the power 0, that is 1. So this into 2 minus 2x is outside. ddx of 3x cubed. 3x cubed is of the form a x to the power n. And this becomes n a x to the power n minus 1. Please remember the first formula which we did. So therefore, this will become 3 into 3x squared plus 7. 7 becomes 0 because differential coefficient of 7. 7 is a constant number, so it becomes 0. This divided by 3x cubed plus 7 whole square. So let us simplify this further to see what we get. So this becomes 6x cubed plus 14 minus 2x, this becomes basically 9x square into 2x. So 18x cubed. So minus 18x cubed divided by 3 3s are 9 2s are 18x cubed. This becomes 3x cubed plus 7 whole square. So if you simplify, this becomes 6x cubed minus 18x cubed. That is, it becomes minus 12x cubed plus 14 divided by 3x cubed plus 7 whole square. Okay? So this gives you the full application of the quotient of two functions. So we have considered 2x as u and 3x cubed plus 7 as v. So the given function y is of the form u divided by v. So as per the division rule, as per the quotient rule, we have first kept v outside and differentiated u first, and then minus u outside, differentiated v first, divided by v square, and v you know is 3x cubed plus 7, and the rest as followed normally. Fine. Rubbing this up and moving on to the next one. Okay. So we shall see some further rules of, not rules, but I will call it formula. I think rules we have seen almost all of them. Just a few formula. We will take, so we have done, you see the first formula was product x to the power n. Then we did the formula for a constant. Derivative of a constant is 0. The third one we did was the formula of a x to the power n, and you remember the differential coefficient becomes n a x to the power n minus 1. Then we worked on the addition formula, and then we took up the difference of two functions, then the product, and then we have seen the division formula or the quotient formula. Fine. Now we are taking up 2 or 3 more formula, right, or rather equations, so you can call it. You see in the study material you will find there is a constant if y is equal to e to the power x. Okay. Now what is e? Or when you go through the study material or when you hear the word e, you will find what is e. E is a constant. Yes, we can understand. It's not a variable like x or y. Actually, e, if you see, is an exponential constant. I'm just writing exponential constant. It is widely used in mathematics and mathematical finance. It's a separate subject, mathematical finance, right? And just as I gave the example of pi, which is 22 by 7, so this e approximately comes to 2.718. The value of e is 2.718. So it is an exponential function, exponential constant you can say, and within our curriculum, within our syllabus, we have differential coefficient of e to the power x. So this one is FGH, so e to the power x. So the differential coefficient dy by dx of ex, e to the power x, very easy, don't have to remember, it will be the same. So e to the power x will remain e to the power x. Okay? Somebody seeking the proof, again as I said, not within the scope of our discussion, neither in the exam you will be required to prove this, but if you want to have the proof, the same formula, fundamental formula, f of x plus h minus fx by h as h tends to 0, limit h tends to 0. There, instead of fx, if you put ex, that means if you prove like this, e of x plus h minus e to the power x by h as limit h tends to 0, you will get the same answer. Okay? So in this way you can prove different formula by yourself. Okay? Using the fundamental principle. Hope it's clear? We now move on to the other one. After ex, this is formula number h. Now we go to the next one. I will take y equal to function of x, a new one. I will take a to the power x. Okay, a to the power x. So we have seen e to the power x. Now we see a to the power x. Now if you find out the derivative of this function a to the power x, now a is a constant. x is a variable. So what will be the value of dy by dx, right? So here, dy by dx, as per the standard results, this will be equal to a to the power x into log a. Okay, so a to the power x into log a, but this is to the base e. Normally logarithms, I am not going into logarithms, you don't want to deviate from the given discussion, but I am forced to deviate because this is on log. Now you know that you have read about logarithms to the base 10, but this is logarithm to the base e, natural logarithm, and it is often known as ln. It is written as ln a. So instead of log a, if you see ln a, it means it is log a to the base e. Fine, that much is enough for our discussion. So a to the power x into log a to the base e. This is formula number GHI. A to the power x we have done. Now we are taking up the next one, a very simple formula. What happens when you are given, say, y is equal to log x, okay? What happens when y equal to fx and function of x, and this is equal to log x? Very simple, dy by dx when y is equal to log x. Please note the formula is dy by dx will automatically become 1 by x. Okay, using the same principle, fx plus h minus x minus fx by h as limit h tends to 0. If you do it, the same results will come. That means the formula, once again I am writing for those of you who are very much interested to know the proof behind this, it is limit h tends to 0. So instead of log x, you write log x plus h minus log x by h. If you simplify this, work it up, it will give you 1 by x. Fine. So this is formula number J. So I'm keeping a note of the ones we are doing. It is log x derivative, so it is 1 by x. And I have also explained what is meant by E. E is 2.718 approximately. It's a constant used in mathematics, and it is basically, as I said, natural logarithm. So ln, I was writing ln here. So it is a natural base for natural logarithms. Fine. Let's proceed on, and now we have done almost all the rules. All the rules are done, and we will take, as we are nearing 1.5 hours, we have half an hour to complete. So we have discussed about addition, subtraction of derivatives, the product rule, the division rule, the quotient rule, and we have taken the formula for x to the power n, a x to the power n. We have taken the formula for y equal to a to the power x, which is a to the power x into log a, and we have taken the derivative for log x, which is equal to 1 by x. Fine. Some quick exercises let us carry out, miscellaneous work, so further improves your concept and your skill, okay? Because from this chapter definitely questions will come in the exam, and there will be 2 or 3 types of questions. One of them will be on derivative, one can be on the applications which we are about to do, and one can be on implicit functions which we will do. Okay. So I'm taking, let's take this one. Fx is equal to x to the power, say minus 3. Derivative. Dy by dx. So f dot x, that is dy by dx, is equal to x to the power n. So it will be n x to the power n minus 1. Correct? So this is n is minus 3. So it comes down n x n minus 1. So minus 3 minus 1. So this becomes minus 3x to the power minus 4. Fine. Let me take, okay, let's try this one. This is of course implicit function. So we have done ddx of x is 1. We have done the addition rule, subtraction rule. I'm just looking at the list of the standard formula in my laptop. u plus v we have done, u minus v we have done, uv we have done, u by v we have completed, e to the power x we have completed, trigonometric function is not there, u by v we have done, log x we have done, a to the power x we have done, fine. So for the exam syllabus we are through. Now we will take implicit functions. Okay. Now implicit functions, let us take a simple example. We'll take two examples, implicit functions. First, let me do the chain. This is also called the chain rule. The chain rule. Okay, it's like a chain linked. Chain rule. The chain rule is this, very simple. dy by dx is equal to dy by dv into dv by dx. So dv cancels out. I am writing dy by dx into two functions, splitting it into two functions. So this is nothing but dy by dv divided by dx by dv. So this is called the chain rule, and you can see why it is a chain, because dv. It's like a chain, forming a chain, right? And let me take an example to clarify this example, right? This formula. I'm taking fx. So let it be like this, y equal to 2x square plus 1 to the power 5. Please see the given expression. Y is equal to 2x square plus 1 to the power 5. Okay, so we apply this chain rule, implicit function. Okay, so what we do is, we are assuming, let 2x square plus 1 equal to v. So here I have taken v, just taking an example. Instead of v, you can take L, J, K, whatever you want. Okay, so here we are taking 2x square plus 1, let it be equal to v. Correct? Therefore, y now becomes 2x square plus 1 is v. So it becomes v to the power 5. Great. Simplified. Right? Now, the formula is dy by dv divided by dx by dv. So here, dy by dv is what? V to the power 5 means what? The differential coefficient will be x to the power n. So nx to the power n minus 1. So this will become x to the power n, v to the power 5. So this will become 5 into v to the power 5 minus 1. First part is done. dy by dv is done. Now we are taking dv by dx, that is dx by dv, or dv by dx. Okay. So this is a 2x square plus 1, that is v. So if you take dv by dx, this is ddx of 2x square plus 1. 2x square plus 1. So this will give you ddx of 2x square, a into x to the power n. The formula we have noted is n into a to the power x minus 1. So this will become 2 into 2 to the power x 2 minus 1, that is 4x. Okay, so we have got the formula. The formula is dy by dv into dv by dx. So dy by dv we have got. dy by dv is 5v to the power 5 minus 1, that is 5v to the power 4. Now v is 2x square plus 1. Therefore, the answer is dy by dx is equal to 5v to the power 4, that is 2x square plus 1 to the power, because 5 I have to write 5 into v to the power 4. So 2x square plus 1 to the power 4 multiplied by this 4x, because dv by dx is 4x. So multiplied by 4x. So if you simplify this, it becomes 5 into 4x, 20x into 2x square plus 1 to the power 4. Once again, please have a look. The formula for chain rule or implicit functions is dy by dx is equal to dy by dv into dv by dx. So we break up dy by dx into two parts, dy by dv into dv by dx. So what we have done, we have taken y equal to 2x square plus 1 to the power 5. So we apply the rule and we are assuming 2x square plus 1 equal to v. So we first do dy by dv. How we are doing it? We are just finding v to the power 5. The differential coefficient of v to the power 5 is 5v to the power 4. This is the first part. The second part is dv by dx. We have done it here. dv by dx is ddx of 2x square plus 1. So it gives me 2 into 2x to the power 2 minus 1, that is 4x. So when you multiply all through, you get 5 into 2x square plus 1 to the power 4 into 4x, that is 20x into 2x square plus 1 to the power 4. Okay, so this example you will see in page number 8.8. I have taken this from the study material for discussion because many of the examples are worked out, but then the meaning of all these sessions is to explain the examples. Right? If everybody understands the examples and understands the chapter, then no need for these sessions. Okay? So the idea is to simplify many of the examples, make you understand step by step, and then take up some exercises so that within this given hour, a time of 2 hours, we are able to do as much as possible. Of course, after that, you have to study on your own as well and make sure you understand the chapter and you are confident about it. Fine. Let me take now logarithmic differentiation, another small part of logarithmic differentiation. After that, we will go to the last part, which is the applications of differential calculus in economics and business. Okay. We are taking logarithmic differentiation, so we have done the chain rule as well. I will just keep a note of that. So we have done the chain rule, so I and j, we have done the chain rule. And we are now going into K, that is the logarithmic differentiation. Right. So we are moving on to HA7. So I request you to move to HA7 on logarithmic differentiation, 8A.7 of the study material, logarithmic differentiation. Now, an example we're taking now, x to the power x. We have to find out ddx of this. So if y equal to x to the power x, then dy by dx is what? Okay, so please have a look at the problem. Okay, let me take this. So this is a special, special technique which is called logarithmic differentiation. Logarithmic, and once again, since this is the last chapter of business mathematics part, and calculus is the last part, differential calculus we are doing today, next day integral calculus. So we are assuming that you have complete idea of logarithms. You are clear about it because here we are applying logarithmic differentiation. So what we do is x to the power x is equal to y. You have to find out dy by dx. So what we do is we take the log of both the sides, left hand side as well as the right hand side. So let us see what does this give us, Okay. So we find out log y is equal to log x to the power x, but you know that x to the power x means you can break it into x log x. I'm not going into the rule because I assume that you all know about logarithms completely. So you have log y is equal to x log x. Okay, but log y, if you take the derivative now, okay, log x or log y, the derivative is what? 1 by y. Right? We did the log formula number j, which you must have noted down on log x. So this will become, I can write, this will become 1 by y into dy by dx Now this is equal to x log x. X log x. So I have to find the ddx of that. So ddx of x log x. So this is equal to x log x is a product. There are two functions. The first function is u and v. So the first function is u is x here and v, the second function is log x. So we are applying the product rule because we are dealing with x log x. It's a product of two functions, x and log x. So we have to follow the product rule and we have already done the product rule. I will refer it. The product rule is formula F, which we have covered. So here we apply the product rule and what we do is we find out, first we keep x outside and we do ddx of log x, plus we have log x outside, we do ddx of x. So this gives me x into ddx of log x. Log x ddx is 1 by x. So it becomes x into 1 by x plus log x is outside. ddx of x. ddx of x is what? It is 1 because x to the power 1. So x to the power 1 minus 1, that is x to the power 0, it becomes 1. So this is into 1. So what I am getting, 1 cancels out, it becomes 1 plus log x. Okay, 1 plus log x. Now the question is here we are having 1 by y dy by dx is equal to 1 plus log x. But if you see, we have y is x to the power x. So I can write from here 1 by y dy by dx is equal to 1 plus log x. So I can write dy by dx is equal to y will now come to the other side in the numerator. From the denominator on the left hand side, it will come to the numerator in the right hand side. So it becomes y into 1 plus log x. Because already this side we have 1 plus log x. But here y is equal to what? Y is equal to x to the power x. So the answer is x to the power x into 1 plus log x. So dy by dx is equal to x to the power x into 1 plus log x. This is the answer. I think it's clear. What we have done is logarithmic differentiation. When you are given this type of expressions, we take the log of both the sides. It becomes easier for us to find out the differential coefficient. So we took 1 by y into dy by dx. This side it is ddx of x log x. Now x log x is of the form u into v, where u is the first function, v is the second function, u is x and v is log x. So we applied the product rule, which I have discussed already, and we have applied it to get the solution 1 plus log x. So the equation becomes 1 by y dy by dx equal to 1 plus log x. So y goes to the numerator on the right hand side, but y is x to the power x. So it becomes x to the power x into 1 plus log x. Okay, fine. Now we go into 8a9. Looking at the time, we have time for two more areas. That is, we will take up the basic idea about higher order differentials and then we will move on to the application. So I proceed to 8a.9, which talks about higher order differentiation. Now, what is higher order differentiation? Now, say you are given y equal to fx. If you find out dy by dx, fine, dy by dx, okay? So when you write dy by dx, this means f dot x. But if I tell you that you differentiate this once again, dy by dx, you have to differentiate. That means now I am asking you to do ddx of dy by dx. In this case, we call it second order derivative. Only dy by dx is first order, first degree. Okay? Now, ddx of dy by dx, that means it will become f double dot. 2 times. First order or first degree is f dot x. It is denoted by f dot x. But second order differential is denoted by f double dot. And this is shown by d square y by dx square. Degree is 2. The order is 2. Similarly, if somebody asks you to differentiate this expression once again, if you are asked to find out the differential coefficient of the derivative of d square y by dx square, then it will become ddx of d square y by dx square. So this will be f triple dot 3 slash 1, 2, 3, 3 slash x. That means d3y, d cube y by dy, dx cube. So this becomes first degree, first order, this becomes second order, this becomes third order. Okay? So we will take one example only to just illustrate this and you will be clear. So this is what is called higher order derivatives, which is higher than first degree. Or with me plus 5x cube plus 2x square plus 9. Okay? So this is the given expression. We have to differentiate it till 3 times. So we have to find the third order differential or the third order derivative. Clear, students? I hope it's clear. So the first order, second order, third order. So first order, I am writing first order derivative d, that is dy by dx, also shown as f dot x. So I am differentiating it directly using the addition rule because it is also addition. So x to the power 4, the differential coefficient of x to the power 4 will be 4x cube. So I am writing 4x cube plus 5x cube, differential coefficient of 5x cube, directly I am writing 5 into 3x square. So this will become 15x square plus 2x square, differential coefficient is 2 into 2x, that is 4x. So I write 4x. 9, the differential coefficient is 0. So this is the first order derivative. Now we go to the second order derivative, that is I am writing second order derivative. Okay, so after this we have done, just I'll keep a note, L, higher order derivative. We have done. Okay, so dy by dx, now we find d square y by dx square. So derivative of this, so 4x cube, the derivative will be 4 into 3x square. So 12x square plus 15x square, derivative 15 into 2 into x. So 30x plus 4x, derivative is 4. So it is 4. This is the second order. Now we have to find out the last one, third order derivative. So I am writing the third order or the third degree derivative, that is d cube y by dx cube. 12x square. So we differentiate this once again. We are differentiating it once again. So we are getting 12x square. The differential coefficient is 12 into 2 to the power multiplied by x to the power 1. So it is 24x plus 30. 4 will become 0. So we get 24x plus 30. This shows the concept of first order derivative when you differentiate it once. Second order, which is shown by second order d square y by dx square, shown by f double dot x, and third order derivative, third order, shown by d cube y by dx cube, 24x plus 30, also known as the third order, f dash 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 x. I'm sure it is now clear to you, dear students. With this, we proceed to the geometric interpretation of derivative and the concept of maxima minima, and then we shall move into the last part, which is the application of differential calculus. So I think we will stretch 15 minutes only, and 4:15 we will complete, right? Fine. So we are taking the next part, and this is the slope of a curve. So I would put it in this way. Say a straight line goes like this. This is the x-axis, 0, and we have the y-axis. Okay. This straight line represents the different values of x, and the vertical axis represents the value of y, and y is equal to fx. That is, y is a function of x, dear students, and x is what? Is it the dependent or the independent variable? So it is the independent variable, and therefore y is the dependent variable. Now the question is, say for example the graph of the equation is like this. When you plot the equation graphically, right? Now the derivative, that is dy by dx or delta y by delta x, which I discussed in the very beginning, actually measures the rate of change. I am writing here the rate of change in y for a given change in x. If x changes, then y will change. What is the impact of the change in y? Now, geometrically, it is proved that once we talk about, the change, what we are actually doing is, say in this particular part, say I want to find out the concept here, the change is here. So, okay. So, say for example, the change, right, will be shown by the tangent, this tangent. This change, the rate of change will be shown by the tangent. I'm sure you know the tangent. In a circle, for example, the tangent is like this, right? Tangential, tangent. So the geometrical definition of the derivative is that the slope of the curve, the curve which is going, the slope of the curve is basically given by the tangent. Tangent, you know, is this line which is going, and tangent is basically given by a formula. Now if the curve is going like this, for example, tangent is this. If the curve is going like this, the tangent is this. So that the tangent will be given by the formula. So if I just expand this triangle, you can see it's a triangle. If I expand this triangle, 1 and this 2, it's a right angle triangle. So the tangent is this one. This is becoming the tangent. And the formula is nothing but, you know, if this is A and this is B, tan theta, tangent of theta is A by B. So the slope, geometrically speaking, derivative means tangent. Okay? Tangent to a curve. Tangent. So, tangent. This is how it is shown. Right. So, any graph, any function can be graphically shown like this, and the derivative at a particular point, the differential coefficient at a particular point means the tangent at that particular point, and that is measured by the slope, and slope means this, slope, tangent, steep, but this is not steep, okay, inclined plane, not steep, but as I increase theta, say this is angle theta, okay, the angle made by my right hand and my left hand, here is the angle theta. As I increase theta, okay, the angle increases, it becomes steep, tangent increases and derivative increases, okay, because tangent is this by this, perpendicular by base, okay, as I move on, theta increases, so tangent changes, okay. Let me take one example of this. The example is a curve is given, a function is given, function of a curve, that is of course a quadratic function is given. We have to find out the gradient or the slope. So it is given that y equal to function of x, this is equal to 3x squared minus 5x plus 4, and we have to find the gradient of the curve at the point at 1, 2. Please see the question. We have to find the gradient of the curve at the point 1, 2. Y equal to fx 3x square minus 5x plus 4. Okay. Now, what we do is, we have understood one thing, that the gradient means the slope. So please note, this is a new term for many of you. Gradient means slope. And slope is this. Okay. As theta increases, my hand is moving like this. My palm is moving up. As theta increases, as theta is increasing, the slope becomes more steep. Here, for example, say this is the vertical. Okay, this is the vertical. Okay, I'll just draw an angle here. My arm and the vertical, say theta, 30 degree. This angle is 30 degree. The slope is given by this. Slope of the gradient is given by this. Many of you stay in hilly areas, mountainous areas. You have been to hilly areas. Higher the gradient means what? The slope. How steep it is. Flat condition. Like the road in Delhi, Mumbai, okay, Chennai, flat. You are increasing the gradient. Theta is increasing. Now from 30 it becomes 45 degree. This angle is now 45. Increasing further to 60 degree. So this is now 60 degree. Increasing further to 90 degree. 90 degree. Okay. So this is the slope. Slope is changing at every point. As theta moves, it becomes more steep. The slope increases actually. Okay. Slope increases because here the slope is this much by this. This much only. But as I increase the slope, please see, the vertical component increases and the horizontal component reduces. As I increase further, 75 degree, the vertical component is this much, vertical is this much, horizontal is this much. So slope increases. The steepness increases. And as I bring down theta, vertical component reduces, horizontal component becomes more. And you know the slope is this by this. Vertical by horizontal, V by H, vertical by horizontal. As I increase it, vertical component becomes longer, horizontal component reduces. I increase it further, vertical increases, horizontal reduces. At 90 degree, technically speaking, it will become undefined. Why? Because at 90 degree, the horizontal part is 0. Anything divided by 0 is undefined. So at 90 degree, the slope is undefined. And you will remember, some of you, that tan 90 is undefined. Okay? So mathematics is beautiful. Apart from being an important part of our foundation paper, if you go deep into it, and now you can see that we will find out the tangent or the gradient. Now I hope gradient and slope concept is clear. We will find it for the given equation 3x square, I'll just write it once again, 3x square minus 5x plus 4. And the point is given at the curve. The point on the curve is given, so it is 3x square minus 5x plus 4, and the point is 1 and 2. I hope you could understand how theta changes and how the slope changes. Here the slope is this by this. As I increase, slope is the vertical component increases. Horizontal decreases. I increase it further. Vertical increases further. Horizontal decreases. At 90 degree, it becomes undefined. So this, we will find out the differential coefficient. Okay, so you can see we are discussing since 2 o'clock non-stop. It's 4 already. So 2 hours over. If I stop here, then it will be incomplete. So I have to push further. Some of you might be having problems, but I can't help it. Right? We have to stretch a little further. Right? Because the subject is tough. It is not a joke. This chapter is not a joke. Each and every concept is important. And the numericals are important. So you could see the time I spent only to explain you gradient. What is slope? Okay, so let us see how we differentiate this. So directly dy by dx, so f dot x, of course, this will be 3x square minus 5x plus 4 differential coefficient. Now I assume that you have understood the basics, so directly I go to differentiation. 3x square will become 6x, minus 5x will become minus 5. So this is the gradient. This is the gradient or the slope. But I have to find out at what point. That means what? The curve is like this. But I have to find out the slope at a particular point. And the point is given 1 and 2. That means x is 1 and 2, y is 2. So at this point I need to find out. Okay? This is y-axis, this is x-axis. This point is P and this is Q. So I need to find out the gradient of the slope at Q, and the coordinates of Q is 1, 2. That means horizontally you go 1, x-axis 1, vertical 2, 1, 2. Okay? So this is what I need to find out. So 6x minus 5 is the tangent, is the equation of a tangent. Please note that it has become linear. We don't have quadratic. Quadratic is here. This is linear. X to the power 1, which means what? The equation of 6x minus 5 is a straight line. It further proves that if the curve is going like this 6x minus 5 is a tangent. That means it will go like this, tangent. Okay? So, at the point x equal to 1 and y equal to 2, so the value is given, x is 1. So I will put 1 in case of x. In place of x, so it becomes 6 into 1 minus 5. That is 6 minus 5, that is 1. So the gradient is 1. Okay? So this is how we solve this type of problem. Now, exactly 4, but we take up the last one, and that is the applications of differential calculus. Okay, fine. So now I will go into the applications. Applications are many applications. Many of them I have already discussed. First of all, I will say the applications. So this is the last part. Higher order is done, and slope is done, gradient is done, and now is the higher order is done. So applications, apps, fine. We go into the applications. First, of course, is we know that it's a ROC, rate of change. Derivative is a measure of rate of change. How can you apply differential calculus? Wherever there is a rate of change, we can calculate that using differential calculus. It could be rate of change in price. It could be the ROC, the rate of change in demand. Right? You can see how economics, how we use mathematics for economics. Mathematics is used everywhere. Mathematics is used in accounts. Mathematics is used in economics. Statistics is used in economics. Okay, so mathematics is like a feeder subject which supports other subjects. That is why we learn this chapter in CA Foundation. Many of you are asking me, why matrix, sir? Why APGP? Why set? There is a reason. That's why this institute has included these chapters. Okay, so demand. The third one. When there is a change in, say, savings, rate of change in savings, rate of change in consumption. Okay? Now, change in demand will take place when there is a change in price. Change in savings will take place when there is a change in income. Change in consumption will take place when there is a change in income as well as price. As simple as that. My income has reduced. I was working in a company due to, say, lockdown and this thing. I am getting only 10 or 20% of my salary. My income has reduced. The prices of commodities have gone up. Inflation has gone up. I explained about inflation in the time value of money chapter. So, my consumption will fall. Rate of change. Okay? So, consumption. And these are economic terms. I'm sure you have learned these things very well in economics. Plus, calculus and differential coefficient also helps you in, most importantly, in physics as well. Okay, we go to page 8.15 to see the last part. So I'm sure you understand this. Rate of change in price, rate of change in demand, rate of change in savings, rate of change in consumption. Okay, now we will see a numerical and then we will understand how it is used. Let me go to a small example, and this is the example. Okay, the demand curve, okay, the demand curve of a particular company is like this. P is equal to 17 minus 3Q, okay, where Q is the output or the quantity. Q is the output or the quantity, okay, and the demand curve is given by P equal to 17 minus 3Q, right. So Q is the output, this is the demand, okay. Now we have to find out total revenue. What will be the total revenue of this company and what will be the marginal revenue? You know the marginal revenue or MR. You have learned it in economics. Marginal cost is the cost of producing an additional object, additional item or commodity. Marginal revenue is the additional revenue I earn for selling an extra item, an extra unit. Fine. So therefore, here we are dealing with the marginal concept and we have to find out the marginal revenue. First of all, 17 minus 3Q which you see here is what? It is basically the demand curve, the demand. And you can see that P and Q are related because the demand depends on the units of quantity you are producing as well as the price. Now the question is here, P of course is the price and Q is the quantity. Now we have to find out, the first question is total revenue, TR. You know the total revenue of a company is what? The price into the quantity or the demand. I know the demand is this much. I know the quantity. And so P into Q. So since P is given, I multiply that by Q, right? So I use the formula P into Q. So this is P into Q. So 17 minus 3Q into Q. So the total revenue is given by 17Q minus 3Q square. 17Q minus 3Q square gives me the total revenue of the company, of the particular entity. Now all of you know some basic concepts. I'm just needless to mention, but I'm still repeating, you probably know it very well. You know that some economics concepts I'm just writing. Total cost, TC, you know this is equal to fixed cost plus variable cost. First, you know the total revenue of a company is price into quantity. Price P into the quantity, right? The third one is profit, okay? Profit is nothing but total revenue minus total cost. And you also know that profit becomes maximum. Profit becomes max when the marginal cost is equal to marginal revenue. So when MC equal to MR, you have the maximum profit. So this I think is known to all of you. 1, 2, 3, 4. Right? And last but not the least is break-even point. BEP. Break-even point means no profit, no loss scenario. Once you cross the break-even point, you start earning revenue. And you definitely are earning revenue means you earn net profit. Right? You earn revenue in a positive way because your revenue will be more than your cost, which means you make profit after you cross the break-even point. So break-even point can also be discussed as indifference point, no profit, no loss situation. So in this case, dear students, what we have seen is 17Q minus 3Q squared gives you the total revenue. Now second part is marginal revenue. The question has two parts. First part is total revenue, second part is marginal revenue. Marginal revenue equation is what? Marginal revenue, you see, as I said, derivative is used to find out marginal cost, marginal revenue, rate of change. So here, MR will be equal to dq of this expression 17q minus 3q square, because 17q minus 3q square is the total revenue and the derivative of the total revenue is the marginal revenue. Okay, therefore we are applying the concept of derivative directly here, and what we are getting, ddq of 17q minus 3q square, 17q is becoming 17 minus 3q square becomes 6q. So the marginal revenue equation is given by 17 minus 6q. Okay. Now we will take the last one, that is page number 8.16. I request you to move to page number 8.16 and we will solve this one. Okay. So page number 8.16. So we have already discussed the applications and the economic concept also we have done, and we take 8.16. Page number 8.16 please, and let us take the problem there. Okay, so example 2, and this is 8.16 example number 2. The cost function. So the cost function Cx is given by 100x minus 8x square plus x cubed by 3. This is the cost function. Please note the problem. The cost function of a company. So this is the cost function. Cost function is given. Of course, here x is the output. X is the output, okay? So we have the cost function is given and we have got the output is x. 100x minus 8x square plus x cubed by 3. Here x is the output, kindly note this. Fine. Now the question is, find the level of output at which, that means you have to find at what x, what is the value of x, where the marginal cost MC is minimum and the average cost AC is minimum. Okay, I am not going to definitions because again that is beyond the syllabus of this chapter. We are strictly following exactly which is there in the syllabus, nothing extra given the time we have, and therefore MCAC, I am assuming all of you are clear about marginal cost and average cost. So in this case, marginal cost as per the derivative concept is what? This is the cost function is given. So since the cost function is given, we will find out the marginal cost is given by MC is ddx of Cx, where Cx is the cost. So if you find out the derivative of the cost function, you will see the rate of change in the cost. And rate of change is another way of expressing marginal cost. That means if I produce one more item, what will be the change in the cost? What is the delta impact in cost? So it is a rate of change, ROC, rate of change. Therefore, let's see what happens here. So 100x minus 8x square plus x cubed by 3. This is my total cost equation. So I will find out the derivative of this equation. So ddx of the given equation is 100x minus 8x square plus x cubed by 3. Now that we have covered the details of the entire formula, so I directly go to the differentiation. ddx of 100x will become 100 minus 8x square, ddx will become 16x plus x cubed by 3. Now plus x cubed by 3, it will become plus 3x squared by 3. So it will become 100 minus 16x plus x squared. 100 minus 16x plus x squared. So this is the marginal cost. MC is this. So once again, we have found out the derivative of the total cost to get the marginal cost. You can see the direct application of differential calculus in economics. Now the question is, this is the formula, that is 100 minus 16x plus x square is the formula for the marginal cost. We have to find at what output the marginal cost is minimum. Now the question is, for this, we have to differentiate. That is, we have to find out the derivative of MC once again. That means here we are going for second order t square y by dx square. And the formula is, the concept is, when you have to find out the value of the marginal cost, at what output the marginal cost becomes 0. The concept is to go for differentiating marginal cost dmc of dx and equating it to 0. This is the formula. So what we do, 100 minus 16x plus x square, we find out the differential coefficient once again. So this becomes ddx of 100 minus 16x plus x square. So this becomes 100, ddx of 100 is 0, minus 16x becomes minus 16, plus x square becomes 2x, this is equal to 0. So we have the equation 2x minus 16 is 0. So x is equal to 8. So we have got the answer at x is equal to 8. That means when the output is 8, at that stage, marginal cost will become minimum. So this is called minima condition. Okay? Marginal cost is 0, the lowest. We have to find out when it is minimum. Similarly, sometimes in the problem it may be given, find the point where marginal revenue is maximum. Marginal revenue is maximum, marginal cost is minimum. Fine? So this is how we have found out. Now we go to the average cost. Next question is when average cost is minimum. Okay, now we have already got the formula for the total cost. So I am rubbing this part. Marginal cost is done and the output is 8. Fine. Marginal cost is done, the output is 8. So now we go to average cost. You know average cost is equal to total cost by what? The total cost divided by the quantity x. So we have total cost 100x minus 8x square plus x cubed by 3. This divided by x. This gives me the average cost. So the average cost comes to 100x by x, that is 100, minus 8x square by x, that is minus 8x, plus x cubed by 3 divided by x, that is plus x squared by 3. So I get the average cost also, and similarly here also I can find out when the average cost will become minimum by finding out once again differential coefficient of the average cost. If I do it, I will just write it here. If I find out the differential coefficient of this one, average cost, this is AC, average cost, then the differential coefficient will be 100 will become 0, minus 8x will become minus 8, plus we have x squared by 3, so it will become plus 2x by 3. So minus 8 plus 2x by 3 will become 0, and if you solve this equation, you will get x is coming to 12. X will be equal to 12. That means the answers to this question is when x is 8 units, then marginal cost is minimum when x is 8, and when x is 12 units, when the company is producing 12 units, then the average cost is minimum. Okay. With this, we move to the last example for the day and we will wind up with that, page 8.17. I move on to page 8.17, the last example given, and page 8.17. Okay. Here we have to find out, example 3 we are doing, page 8.17. Fine. Example number 3, 8.17. So, a computer software company wishes to start production of floppy disk. Fine. a very old problem because you have floppy disk. No, you will not find floppy disks anywhere. That was a time when we were students and we were chartered accountants. We became CAs those days. Okay. It was observed that the company had to spend 2 lakh for the technical information. Fine. The cost of setting up the machine is 88,000. So 88,000 is the cost of setting up the machine and 2 lakh for the technical information. So 2 lakh for the technical information, fine. And the cost of producing each unit is 30. So the variable cost is 30, while each floppy could be sold at 45 rupees. So the sale price or the revenue per unit is 45. The variable cost per unit, of course, is 30 per unit. Fine. We have to find out the total cost function for producing X number of floppies and the break-even point. Fine. So here you can see 88,000 is for setup and 2 lakh for the technical information. So together the fixed cost is 88,000 plus 2 lakh, that is 2 lakh 88,000. Fixed cost. The variable cost per unit is 30. Therefore, you can see that if I produce X units, then the total cost, total variable cost, TVC, is 30X. So I can find out, the first question is, what is the total cost function? So the cost will be what? Cx, the cost function is what? Fixed cost plus variable cost. So my fixed cost is 2,88,000 plus my total variable cost, that is 30x. This is my cost function. So we have found out the first part. First part is done. The second part of the question is the break-even point. Wonderful problem. Break-even point, you know, is where the total revenue is equal to total cost. So break-even point, BEP, means the total revenue minus total cost is 0. So it gives you no profit, no loss scenario. Now here you see the selling price is 45 per unit. So my total revenue will be, for X units of course, will be 45X. And I know my total cost. So I also know that at the break-even point, total revenue will be equal to total cost, because TR minus TC equal to 0, it means TR will be equal to TC. The total revenue will be equal to total cost. Fine? Therefore, what we do is, we just equate the revenue function and the cost function. Revenue is 45x. So I write 45x is equal to 30x plus 2,88,000. 30x plus 2,88,000. That means 45x minus 30x, that is 15x, is 2,88,000. So x comes to, if you calculate quickly, coming to 19,200. Okay, 19,200. So this x equal to 19,200, which you see here, is the break-even point, BEP. Okay, so in this case, the problem was that we have to, the cost function, we have to find out. Variable cost is given 30 rupees per unit. Selling price is given 45 rupees per unit, and variable fixed cost is given. Two elements, two part of fixed cost is given. From here we have found out the total fixed cost, 30 rupees per unit variable cost. From there I find out the total variable cost, and the revenue per unit is given rupees 45. My output is X, so my total revenue is 45X. So I have got the cost function, because cost means FC plus VC, I have found out, and break-even point we know is where the total revenue equals the total cost. That is what we have done, dear students, and we have equated the revenue function 45x with the cost function. So we have got x equal to 19,200, which gives me nothing but the break-even point. Last, of course, and the study material, the last part, I am taking the last 2 minutes now to complete. and I take the last paragraphs of the study material. So if you see, we are having two concepts here: marginal propensity to consume, marginal propensity to consume. Propensity means tendency. So how much will I consume? How much will I spend? Here consumption means actually spending. How much will I spend? Basically depends on the relation of my consumption with my income. So marginal propensity to consume is nothing but the relation of income and consumption. First, that means this is defined as the change in the consumption, delta C by delta I, where C is the change in consumption and I is the change in income. So in the language of derivative, now that you know in details about the concept of derivative, the rules, the formula, etc., I can write this is dC by di. Differential coefficient of the consumption function divided by, with respect to the income function. And of course, the first one is this and the last one is the marginal propensity to save. The marginal propensity to save, that is MPS. This is marginal propensity to consume, MPC, and this is MPS, the marginal propensity to save. Now saving, you know, if I write saving is equal to my income minus my consumption, income minus my expenditure. So my marginal propensity to save depends on basically my income. As income goes up or comes down, definitely my saving will undergo a change. So this also can be said to be the rate of change in saving, delta S by delta I, where I is my income. So this is ds by di. The differential coefficient of the savings function divided by, with respect to the di, you can say. That means if the income function changes by a small amount, what is the impact on the savings? And savings means my income minus my consumption. So dear students, this brings us to the end of the chapter on differential calculus. We have discussed about limit. We talked about the formula of limit. We went into the concept of derivative. We did the addition rule, the subtraction rule, the product rule, the quotient rule, implicit functions we have done, chain rule we have done, logarithmic functions we have done, exponential functions we completed. Then we did the logarithmic differentiation concept. Thereafter we went into the parametric functions and implicit chain rule, and then we have completed the slope or the tangent, discussion of the slope, that is the tangent. We did the graphs and then how the derivative actually measures the tangent and how the tangent changes as theta increases, I discussed. We also did the higher order derivatives, d square y by dx square, d cube y by dx cube. And I explained through examples how we differentiate each expression into the next derivative. Then we discussed about maxima minima, at what point average cost becomes minimum, marginal cost becomes minimum, and we did the applications of differential calculus in economics, in business, and we completed with number of problems and their solution from the study material. So it's already 4:30 almost. I think we have done the complete chapter on differential calculus as per the study material, strictly keeping within the time limitations we have, the time constraints and the time duration we have been given. Thanks a lot for joining. Hope that you go through the chapter, and next day, that is 27th, we will take up the integral calculus part, and with that we will come to the end of the business mathematics section of the syllabus for CA Foundation. Thanks a lot for joining. See you next day on integral calculus. Till then, take care and thanks for joining.